All right, so lesson 1.8 is on the combination of functions. And we're going to do some combining of functions like you guys have done in Algebra 2. And we're going to do a new kind of combination of functions. So the first four are like what you guys did last year. We may write it a little differently, so I'll show you. But the sum of two functions is adding them together. There's two ways that you'll see that written. So it could be in parentheses and then f plus g of x. All that means is take f of x and add g of x to it. All right, difference, same thing, but with subtraction. All right, and then for the product, same thing again, but with multiplication. So in parentheses, you'll just have fg of x, and that means f of x times g of x. Right, and then quotient is division. So it could be written like f and then slash g of x, or written as f of x over g of x. Both of those means you're dividing f of x by g of x. All right, so on examples 1 and 2, we're going to do a lot. We're going to do really five things. We're going to add their functions, subtract, multiply, divide, and tell the domain of the division one. All right, so when we're adding functions and they're like what we see on example 1, it's really easy. You're just going to take the f functions. We're going to find f of x plus g of x. So we'll take the f function, we're going to add the g function to it, and all we have to do is add like terms. So I'm going to add my x's together and get 6x. And then I'm going to add my constants, so -1 plus 5, and get 4. And that's it. We're done. All right, for B, subtraction is basically the same thing, but you have to be a little bit more careful on this subtraction. So we take 2x minus 1, and we're going to subtract 4x plus 5 from it. Now, the parentheses on the first expression don't matter because there's nothing in front of it, but the parentheses on the second expression do matter because we have to distribute that negative. We have to subtract the 4x. We also have to subtract the 5. So a lot of people mess up on subtraction because they don't distribute the negative. Right, then we're going to do the same thing we just did. We have 2x. We're going to subtract 4x from it. That's going to be -2x. And then -1, subtract 5 from it, and that's going to be -6. All right, now we'll do the multiplication. So for C, we're going to take f of x, and we're going to multiply it by g of x. All right, so 2x minus 1 times 4x plus 5. All right. So on this, for multiplying two binomials, we have to do the double distributive property, where we'll multiply 2x times 4x, 2x times 5, -1 times 4x, and -1 times 5. And then finally, we'll combine our like terms. Our like terms are in the middle. Oh, sorry, that was 8x squared. All right, so 8x squared plus 6x minus 5. All right, and then lastly, we're going to find the quotient. Now, you guys are going to like finding the quotient on these. So So we just put, let me write it, sorry. We are going to take f of x and divide it by g of x. So we'll just put f of x in the numerator, g of x in the denominator, and we're done. So quick and easy. All right, now the domain. Domain is definitely something we need to keep practicing. So because I have an x in the denominator, my domain is going to be restricted because that 4x plus 5 cannot equal 0. So that means that x cannot equal negative 5/4. Because if it did, then you would have 0 in the denominator, and that's undefined. All right, for example 2, this one is going to be a little more challenging on the addition and subtraction because I have this fraction. And from what I understand, you guys didn't do a whole lot with rational expressions last year because of COVID. So we are going to add these together. So we'll take f, we're going to add x squared to it. Now, to be able to add fractions, you need a common denominator. And so right now, x squared is over 1. So the common denominator is going to be this one. So this one is missing that x minus 1. So I'll multiply the numerator and denominator by it. All right. Then once you get a common denominator, I like to go ahead and just make one fraction, put your common denominator in the denominator, and then just do whatever it's telling you to do in the numerator. So I have x, and then I have the plus, and then I'm going to need to distribute x squared. Right. And that's it. You can leave it like that. That's perfectly fine. Except it needs to be x squared, like I said. And I did it right. I might rewrite it so that numerator is in descending order. But we can stop. That's it. That's what you get when you add those two fractions together, or those two functions together. Okay, subtraction is going to be extremely similar, and now that we've done the addition, the subtraction hopefully won't be as hard for us because we're going to have the same common denominator. Right, so our common denominator is still going to be x minus 1, so I need to multiply through by that. Right, so since they both have the common denominator, I can make one fraction. I'm going to bring over my x. Now be careful that you distribute negative x squared. So negative x squared times x is negative x cubed. And negative x squared times negative 1 is plus x squared. And again, that's fine. You can leave it like that. If you want to, you can rearrange it so it's in descending order on the numerator. So that's the difference of those two functions. All right. So multiplication and division are going to be so much easier than addition and subtraction. So hang in there. If I want to multiply these together, I'm just going to write it as multiplication. And again, don't forget, x squared is over 1. When you multiply fractions, you just multiply across the numerator and across the denominator. So x times x squared is x cubed. And x minus 1 times 1 is x minus 1. And you're done. All right, for D, we're going to divide f of x by g of x. So this one is a little more challenging than this multiplication, but we'll take our f function and divide it by the g function. So try to think back to when you learned about fractions, I don't know, like 3rd, 4th grade, I don't know. To divide by a fraction, I'm still going to make this x squared over 1. You multiply by the reciprocal. So we would leave the x over x minus 1 alone, just leave it like it is, and multiply by the reciprocal of x squared over 1, which is going to be 1 over x squared. All right, so now I'm going to multiply across the top, multiply across the bottom. I'm not going to distribute quite yet. All right, and then because I have an x on the top and an x squared on the bottom, I can reduce those by an x. And you're left with 1 over x times x minus 1. And if we leave this in factored form, it does make it a little easier for us to find the domain. All right, so that denominator can't be 0, so x times x minus 1 cannot be 0. So x cannot be 0, and x minus 1 cannot be 0, so x cannot be 1. So there's 2 things that have to be left out of the domain. Okay. For example 3, we're going to evaluate these functions. So what we have is just written a little different. Instead of f plus g of x, we have f plus g of negative 2. So think about what you think that means. So what it means is f of negative 2 plus g of negative 2. You guys have been able to find f of negative 2 and g of negative 2 for a long time, since you were in Algebra 1. So f of negative 2 means take negative 2 and put it in for x in the f function. All right, and then we're adding that to g of negative 2, same thing, take negative 2, put it in for x in the g function. Oops. All right, so then I'll just simplify those down. So that's going to be 4 minus 4, which is 0. And then negative 1 plus 1 is negative 1. 0 plus negative 1 is just negative 1. All right, then for b, same idea. We're going to take f of 3 and subtract g of 3 from it. All right, so f of 3, I put 3 in for x in f, minus g of 3, put 3 in for x in g. All right, so that's going to be 9 minus 4, which is 5. 3 plus 1 is 4, so when you combine those, you should just get 1. All right. And then the last part of today's lesson, because we're not going to be able to finish the whole thing, so we're just going to go to halfway down the next page. We're going to talk about the composition of functions. And the composition of function notation is kind of different. So we are going to look at this little circle. So it kind of looks like fog, but it's read f of g of x. So both of those mean the same thing, f of g of x. So you do how you read it. So f of g of x means you're going to take the g function and put it into the f function. So run the g function through the f function. Or you can think of it as substitution. So you can substitute the g function in for x in the f function. All right, so for 4 and 5, we're going to do 3 different things. So we're going to find f of g of x, g of f of x, and then we're going to do g of x. All right, so let's start with g of f of x. Now, I don't like writing it with a little circle. So for g of f of x, I'm going to write it like this because to me, that makes sense. So f of g of x, we're going to take g and put it into f. So I'm going to start off and just replace g of x with what g of x equals. All right. Then I'm going to take that 2x squared plus 2, and I'm going to put it in for x in the f function. So that means I'm going to multiply it by 3. Oops. And then I'm going to add 4 to it. All right, so that's what I'll do. I'll multiply it by 3, and then I'll add 4 to it. Sorry, I left out my square. And that's it. And that's where you stop. So after you combine your like terms, you're done. Please don't try to do more than you have to do. All right, for B, we're going to do g of f of x. All right, so this means that I'm going to take f, which is 3x plus 4. And I'm going to put it in for x in the g function. So that means I'm going to square it. I'm going to multiply it by 2, and then I'm going to add 2 to it. Or you can think of it as substitution. So in the place of x, I'm going to write 3x plus 4. All right, so to square 3x plus 4, I'm going to square 3x. I'm going to multiply these together and multiply by 2. So that's 12x, and then so 24x. And then I'm going to square 4. Okay. Then I'll multiply 3 by 2. And finally, I will add 2. Alright, and then the last thing I'm going to do is C, which is g of g. So in the place of g of x, here, I'm going to write what g of x equals. Which is 2x squared plus 2. Then I'll take that 2x squared plus 2 and replace x with it. So instead of 2 times x squared, it's 2 times 2x squared plus 2 squared, and then plus 2. All right, squaring 2x squared plus 2, you're going to square 2x squared, multiply them together and multiply by 2, and square 2. All right, and multiply by the 2, distribute it, and then add your like terms and you're done. That's a composition. You put a function inside of another function. Okay, on example 5, I'm not going to do the whole thing. I'm just going to do A and B. So for A, we're doing f of g of x. So f of, and then take what g of x is and put it in the place of g of x. So f of x squared minus 3. So I'm going to take that, x squared minus 3, I'm going to put it in for x in the f function. So we have the square root. Instead of x plus 4, we have x squared minus 3 plus 4. All right, combine your like terms and you're done. All right, for B, we're going to do g of f of x. Okay, so in the place of f of x, I'm going to write what f of x equals. G of, g of the square root of x plus 4. All right, then I'll take that square root of x plus 4 and put it in for x. So that means I'm going to square it. And then I'm going to subtract 3 from it. All right, so when you square a square root, it goes away. And then you combine like terms and you're done. Okay, so now that's a lot of new information in one day. But we're going to stop right there. Tomorrow we'll talk about the domain stuff. Your assignment is page 81, 6 through 14 even, 18, 20, 24, 32, and 34. And then, like I said, we'll pick back up tomorrow with the domain.